Hello everyone, how you all doing? My name is Ben and you're welcome to my life. Today we are going to write a simple program that has to do with how pipe works in C programming language. Pipe is a means whereby we can read input from one input to another. Although there are different ways to do these things, okay, but they are system calls already written by top guys, top programmers all over the world, likes like Dennis Ritchie, Andrew Tannerbaums, Brian Kanigan, and the rest of them. Bijan Structman, name them, a lot of them. Okay, they wrote these functions, and it's pretty very awesome. It's a function that one need to learn how to use because it helps you to do things very easy. Although yes, C might not be a friendly human language just like Python and the rest, but it's a language that has to do with the core of the system, not actually core, or not that C can you can use C to be able to generate good hardware code. But one of the benefits of C is that one is a high level language and also a low level language. Low level language in the aspect that you can use C to manipulate memory, set bits according to the size and value you want it to be. So these are great things whereby C can do, like create structures which other language is being known in other language like classes, public and private. So you can do these things or create a union or whatever you just feel like to do. With the power of C, you can do them. Okay, so that is one of the great aspects of C. So related to today's video is talking about the word pipe. Okay, pipe is a system call in C language. Okay, is used for piping whatever you write to the standard output and read it to another input. Okay, we use pipe. Okay, just the way the word sounds. Even in our physical world, we have, someone can just get a pipe will have two hole at the left side and hole at the right side. One of the hole is known as read and the other one is known as write. That is simply what pipe does. So you can pour water from the right hole and it comes out from the left hole. So that is basically what pipe does. Okay, so for us to actually see how this thing is being doing, we are going to write a program in C that will do this for us. So I will just clear my screen and use the mkdir to create a directory called pipe. Enter. I will change into the directory called pipe. Okay, all right, so press enter. Now we are inside the pipe. If I do ls, we see that this directory is empty. Okay, so the next thing is to create a file called pipe.c. Every C program must have the .c extension. Okay, so the .c extension actually tells our CPU how to recognize this program, that this is a C program. Okay, so press enter. So I'll use my Vim, which is a CLI, command line interface applications, for writing code. Is known as editor. You can use any editor of your choice to follow these videos. You can use Atom, you can use Sublime, you can use Notepad++ if you are in Windows, or you can use any pretty good editor doesn't actually matters. Okay, but I like using the Vim because it's wonderful. It's more on keyboards and it allow me to learn most of the keyboard shortcuts. Okay, so I will pass in the name pipe.c and press enter. Okay, there are some pretty header files I'll be including. I've told you guys in all my videos that this hash here simply means a preprocessor. Okay, so what is doing that is including the inclusion of new files called include. And what is the name file we are including? We are including stdio.h. Okay, there are other header files we also like to include, also likes like stdlb.h, okay, and also likes like the unistd, where we can have access to the read and write system call, and also likes like we can include the weight. Okay, .h system call. Okay, so these are pretty four libraries I will be including for now. If there will be need for more, I will just include them as we proceed. So I will create an integer, okay, which is of main, because every function of C must have a main function. I'm not accepting anything into the main parameter, so I just pass it void. So open my curly braces, we just return 0. All right, I close this. Okay, it's not more that our program must always return 0. We can just say void here if we want. You can say void here, okay, if we want. Okay, since I've not been doing this, let me just use voice today in this video. So I'll just remove the return 0. Okay, so the program is not returning anything. So the next thing now is to start writing our program. So what we are going to do now is to I will create an integer of called x comma y. Okay, let me don't put it here, let me make it a structure though. So I will come up here, okay, and I will just create a struct. I'll create a struct, okay, and I will call this struct pipe. Okay, I'll call it pipe, open bracket, and it will take into integer of x, semicolon, and integer of y. Okay, so press enter and I'll close this. Okay, I can give this pipe a name, just call it pipe here and semicolon. So I don't need to include structs in my code anymore to run the pipe. So you get that, right? So the next thing now is to start writing our code. So I'll be using the for. So first thing I'm going to do, I'm going to use the if statement to create a pipe. So every pipe always accept a file description, which I'm supposed to create first. So we'll say the fda, which stands for file descriptor, I will say is of size array 2. So I will just explain this by putting a comment here. So I will say fd 0 for reading, okay, for reading data, okay, and press my enter key and put asterisk here. I will say fd1 for writing data. Okay, I hope this is understood. Yeah, so that is basically the fd0 will be the first file descriptor, while the 1 will be the second file descriptor. Okay, so next thing now is for us to create our pipe. So we use the if statement. Okay, so we call the pipe function. The pipe will take in the file descriptor, and I will say if this is equals to -1, that means we encounter an error. Then what error are we trying? Do we encounter here? So we can say we can use another if to pass in error, but for simplicity I will just pass the error. Okay, I will say pipe failed. Okay, say pipe failed. Okay, put exclamation and close this and close it. Then at the end here I will just exit, since I'm not there's no need to return. Okay, pipe always returns stuff, so I will just return the error. So I return -1, and that is it. Just close this. So that is for shaking the pipe. So this will just create a pipe. What pipe? These two file description of 0 and 1. Okay, for this, for us to now put this into play, there's a function called fork. Okay, so we use the fork to create process. Forks allows us to create process of child and parent. So we are going to say if this is equals to okay, let's say if it is not equals to 0. Okay, the 0 here, okay, this, let me just comment this real quick. Say // say 0 is child process, child 0. Okay, there's no need of commenting it, so let me just write the code. And in writing the code, I'm going to print that this is child process and this is parent process. So when we say not equals to here, for example, that means this fork, whatever it returns is not equals to 0. That means we are in the parent process. That means this process here is the parent process, which will return a value for us. So in this parent process, I will just print f. I will say parent process running. Okay, all right, and that is it. So the next thing now, the parent process, we always wait for the child process to be true. So for that reason, I have to put wait here, the wait system call, and I'll pass it null. my semicolon. So it's going to wait for the child. So instead for the parent to execute, the child will first execute first. Okay, so what the parent is going to do is that it's going to copy whatever the child has, the data of the child, into its parent and print it to the screen for us. So first of all, we use the write system call and we say fd. Okay, fd, which means we are writing to the fd0. Okay, we are writing to the fd0 whatever the child has. So first of all, we have to reference to this pipe, to this structure. Okay, structure of pipe to access the x of the member of the pipe. Okay, so to do that, we use the reference of pipe of the struct. So we say pipe.x. okay, pipe.x, and we'll put our comma and I'll pass in size of struct. I'll say size, I'll pass in size of pipe. Okay, and that is it. So this will just pretty write that to the screen for us. So to check for errors, which is something that is very, very nice, I will just use the if statement. Say if whatever that was returned, okay, if that which was returned, okay, if that which was returned is not equals to or equals to, if it is equals to -1, that means we encounter error. Okay, that means we are saying here, let's go back a little bit and make the screen a little bit smaller. So we encounter error, so we use the p error so that we can know what is happening. So we say failure to write. Okay, failure to write. So put that and we do this, and the next thing we have, because it fails, we pass in exist of 1. Okay, and semicolon, and that is it. Okay, so we write to the file description of 0. Okay, so the next thing here is we use the else. Okay, we say else. So the is else statement will now be the one that we actually write to the read. Okay, so we say now we are writing, okay, to the file description of 1 from the pipe, okay, .y, okay, comma, and then we pass the size of pipe. Okay, so we just here, I would like to check for errors, which is something we need to be doing. You see, if if this say if, okay, we say if equals to, make it a little bit smaller, if this is equals to -1, we encounter error, open curly brace, then here we use the p error to get the error. We say failed writing, fail to write. Okay, fail to write child. Okay, /n, then let this one be fail to write parent. Okay, yeah, so that we know that this error is coming from the parent and this error is coming from what? The child. So before the child process begin, let us just print to the screen. Okay, say child process running. Okay, /n, and that is it. So once we write to X, once we are done checking error, okay, so the shell process writes, and this also this has to read before it writes, because we are reading from the child process. So we have to read first. So we say enter, and here we do the read. Okay, we are reading from okay, let me do write first. Let me do read here. We are reading not writing, because here we need to read from the file description 0 to this address. We make this a character buffer. Let us make it a character. So a character of buff of array 256. Okay, let me just make that. So here we are writing here I will just write hello world. I'll put it hello friends. Okay, so the hello friends will be written to fd1. Okay, so one is being written, so we are reading from that fd1 to 0. So we see in the buffer, so we pass in here, instead of .s we say .buff. Okay, and we get the size of buff, so it will be stored here. So we read from the fd0 to the buff. Then once we are done reading, then we would like to okay, so once we are done, okay, yeah, so that error is being filled. So we like to print now, so we use the print f to say message from child, we say %x \n, and we'll put our comma, and we'll do pipe dot buff. Okay, and that is it. So this will tell us if we actually get the message. Tell us if we actually get the message. If we did, and that ends our inner if, and also ends alright, and that is it. Okay, so if everything work fine, we get first of all, you say it will meet this fork, and the fork will create two process, parent and child. So once it is not equal to 0, which is wrong, because when fork forks, it forks, when fork forks, is it creates two process, parent and children, and the child process. So the child process should run first before the parent, so we are forcing it for the child process to run. But since it's not equals to 0, okay, so we will say we want to go into the parent process, but before the parent process run, we will say we want to wait for the child process to first continue first. So it leaves all the parent process and come to the child process and print child process running, and write this hello friends, incorrect English, hello friends. We write it to the file description of 1 and check for errors. When there is no error, and that is good, then once this is done running, then we go to the back to the parent process, and we continue from this print here, and we'll print parent process running, and we'll read from this file description 0 to the buffer of dot buff. Okay, take the size of the pipe which gives us the actual side and check for error. If there is error, we should have failure to write parent. Failure to write to parent. Failure to write for child. Yeah, so and that is it. So let's check if everything works fine. Then at the end of this, we are supposed to close this file descriptor at each of this. So after the last print, we press enter and we pass in close and pass fd. File description what 0. Okay, and here we also close we also pass the close function. I'll pass file description 1. I hope this is understood. So with everything is now okay. If there should be any error, then we'll just come back and fix it. So guys, let's run this code and see if everything is working fine. There's no need for this inner y anymore because we've gotten what we want. So just close this and clear the screen. Type gcc pipe.c pipe.o, then pipe, remove the .c and press enter. Okay, we got some error here. We're saying the pipe accept file description of 2, 1 and 5 errors. Okay, all right, so I'm making some typing mistakes there, which I will just go down and fix immediately. Yeah, in the child process, we're supposed to pass in e here, and we execute that again. Okay, we return -1 pipe.buff. Okay, is a structure or union. This is a structure, not union. Then we have the print.buff. Okay, we have change return type. Okay, the return type is because since our main is not returning anything, so we should we should as well don't return anything. That's why here where we return something, it gives us error. Okay, especially here now, this is the place we're getting that error from. Okay, so I will just say exit. Since pipe was not able to create, exit with 1. Right, so what's the next error here? We are fixing message from child. That should be spelled correct. Press my enter. Yeah, okay, so 3 errors now. So void and so let me just make the main void because each of these functions are returning something. So let me just remove the void and make it an integer. And we compile again. Now we have just 3 errors. So the main is now off the error. So we say definition of pipe as different kind of symbol. Okay, oh sorry, yeah, so we have a collision here because remember that the pipe here is a system call. So if we are giving this pipe the same name is an error, so we just give it p. Okay, so we say making use of it here, we will now say not pipe, we will say p. We say p and we come here again, so instead of pipe we say p. The same thing will be applied to the child process. Okay, instead of this we say p and we go down and we say p also. I think that is the error we are facing. Okay, let's go fix this. All right, and we run. Our program runs now. So if I do ls, you can see we have pipe. So if I do / pipe and I press enter, you can see child process running, parent process running, message from child process, hello friends. So guys, you see everything is working very fine. We're able to copy the input from the child process to the parent process. You can see child process run first, then when the child process is done, the parent process begin to run, and it tells us message from child process. Okay, so that is simply it. We can as well make this code more involving by editing the code. Instead of writing it, we can read the input. Okay, instead of like writing this hello world like this, we can read it to a buffer, a different buffer inside the array. So I will just do I will do since we are writing to a file, I want the write to I want us to read first before we write. Okay, so I will say p p dot p dot p dot p dot b. Okay, let us call it this time bf. Okay, so that name doesn't sound like, say, buffer, for example. So we'll be reading into this buffer, we'll be writing. So let us first read instead of writing. Let us first read. Okay, so we read from this array. So we read from the input. We are reading from the keyboard. So instead of file description here, we put 0. So we are reading from the keyboard now. Okay, and we are storing it inside this buffer. So the buffer here is character of buffer. We give it the same size, 256, and that will be read. So when that is read, it's time to write. Okay, so we come down here, we now do if again, if open bracket, then now we write. Okay, while we're writing to the fd1 comma, and we read to that, and we are writing okay. Now we are writing from this buff, from this p dot buffer. This p dot buffer, and we are getting the size of pipe of p. Yeah. So we close this, and we say if equals to -1, we encounter error, and we use the p error to know the error we want. Okay, error checking can be done in different ways, which is more professional, and I will do video on error checking, guys. So but for now, let us just keep using the p error. So I will say failed to write to fd, fail to write for child. Okay, that is the error, /error. Okay, I think this will read from the keyboard and write to this file description. Okay, so we can now read from that file description to 0 and print the message out. Okay, so let's do that real quick. So we compile this program again. Okay, it works. So we say pipe and say okay, child process now is on. So we want to say we say welcome to Hackbase C programming tutorial. Okay, so if I press my enter, you see parent process running now. Message from Shide. You say welcome to Hackpace C programming language tutorial. So guys, you see this is very, very awesome. So we get from Shide, then the pipe allows us to copy. When we fork, it allows us to copy that string from the Shide process to its parent process. So the parent process was able to receive something message from the Shide process. Okay, let me make that very clear here. So I'll say message from Shide process here. I'll just put the double arrow sign just to indicate very well. Okay, so and that is it. I think yeah, message from Shide process. Press my enter key. I will just put double new line here. Just put double new line /n again. I for insertion. So /n /n. Those two new lines to make this look good. So I will just compile again. It compiles and I'll do ./pipe Shide process running. So I will say welcome. Say welcome to Hack. Welcome to Pen Academy. Yeah, sorry, oh my goodness, I can't spell academy. Welcome to Pen Academy C programming language course or courses. Okay, so if I press my enter key, you can see we have parent process running. Welcome to Pen Academy C programming language courses. So guys, how do you see this program running? It works very, very fine. So this is a basic way of using the pipe functions in C. Okay, all right, so I hope you guys love this, and if you are doing kernel development, we will use this pipe, fork and exec process a lot in C programming language. Maybe in my next video I'm going to do I'm going to write a very simple kernel so I see how things works beneath the system. So thank you for watching, and it's been education hanging out with you guys. Please make sure you give me a like. Okay, so give me a like, and you subscribe to this YouTube channel, Hackpace. Okay, so that is it. That is pretty the channel. So that's simple. It if you want to go to the channel, this is the https :// make it a little bit smaller, youtube.com/@hackpace. Okay, so that is my YouTube channel. You can see it there. So like, subscribe. Oh, my subscribe spelling is very, very bad, very, very bad, so I will just correct it. So subscribe to this YouTube channel, Hackpace, and the link is this. Okay, https :/youtube.com/hackpace. The same name, Hackpace, is my TikTok channel. Okay, so guys, see you guys on my next video. It's been educational hanging out with you guys. I hope you guys love this and give me a likes and subscribe. Okay, whatever I don't understand, just put it on the comments below and I will never hesitate to reply you. Have a nice day and see you. Bye bye.